In this video, we're going to do binomial distribution probability calculations in Excel. So we're going to be calculating probabilities for things that are binomial distributions, such as flipping coins or anything where you've got just two possible outcomes and the outcomes don't influence each other and they're independent, meaning they're independent of each other, such as guessing answers on a multiple choice test or flipping coins, things like that. Those will be defined by the binomial distribution. Now, we're going to do a variety of similar problems, and they're all going to have to do with coins, and we call them fair coins, meaning that it's really a 50-50 chance between landing on heads or tails, and we're always going to flip 7 coins. So the number of trials, the number of flips, n is always going to be 7. So let's start off with our first question, and it's what's the probability of getting 3 heads with 7 coin flips? Okay, so we're going to flip a coin 7 times and see what the probability of getting exactly 3 heads are. Or it could also be we take 7 coins and flip them and find out what's the probability of getting exactly 3 heads from flipping 7 coins once. Now, we always need to keep track of what the outcomes are, what our P events are, and the P event is going to be getting heads. So it's not going to be getting tails, it's getting heads. The number of P events in this first question that we're interested in is 3, so getting 3 heads, and the number of trials is 7, and the probability P of a P event is 0.5. That's why we're calling it the getting a heads is the P event with a probability of 0.5. Now, another argument that we need in Excel is we need to know, do we want the cumulative score or not? Now, the cumulative score would be the probability of getting 3 or fewer heads. So if you've got the bell curve of the likelihood of things to happen, cumulative would mean everything to the left of the number we're interested in. Now, in this one, since we're concerned about exactly 3 heads, cumulative is going to be false. We want the exact probability of getting 3 heads. So we're going to use the binom.dist command. Now, you can write it in any combinations of capital letters and small letters as you would like. I'm not sure why I did it that way, but it will work. So I need to type in an Excel command, binom.dist, and then we've got to put in 4 arguments. The first one is the number of P events. The number of P events is 3. N is the total number of flips, so I'll put in 7. P is the probability of getting a P event, that's 0.5, and the cumulative is going to be false because we just want exactly 3. And I press enter, and it gives a probability of 0.273438, and I can round that down to the number. So it's about a probability of 0.27 of getting exactly 3 heads with 7 coin flips, which you would kind of expect. You'd expect on the average 3.5, so that's good. Okay, now let's do another variety. What's the probability of getting 3 heads or fewer with 7 coin flips? So the P event here is getting heads, and now the number of P events that we're interested in is 3 or fewer, so that's 3, 2, 1, or 0. The number of trials is 7, and the probability of the P events is going to be 0.5. And here, the cumulative argument is going to be true. We want to calculate the probability of getting 3 or fewer heads. So on the bell curve, we want everything to the left of 3, the 0, 1, and 2 probabilities also, and that will add them all together. So let's type in our Excel command equals binom.dist. The number of P events is 3. Number of trials is 7. Probability of the P event is 0.5. And the cumulative is true. And we press enter. And we get 0.5. And so there's a 50-50 chance that we would get 3 or fewer, which makes sense because we'd expect the average 3.5. So you can't get really 3.5 heads. So 50% would be 3 or fewer. Okay. Now, what's the probability of getting less than 4 heads with 7 coin flips? Okay, this sounds familiar, doesn't it? Previously asked, what's the probability of getting 3 heads or fewer? Here we're asking, what's the probability of getting less than 4 heads? Let's think about that. The P event is getting heads. The number of P events are what's less than 4 heads. So that would be 3, 2, 1, or 0. So we see that is exactly the same thing as problem 2, 3 heads or fewer. Less than 4 is the same as 3 or fewer heads. So we would end up with the exact same formula, equals binom.dist. Then parentheses, we put the 4 arguments. The number of P events is 3. N is 7. P is 0.5. And cumulative is true. Press enter. And we get 50% again. So 2 and 3 are actually the exact same problems, just to show you that less than 4 is the same as 3 or fewer. Now, let's look at what's the probability of getting more than 3 heads with 7 coin flips. Okay, so now we're looking at on the bell curve, we are looking at the right side of the bell curve. But our binomial distribution defines things in terms of what's left to our point. So let's think this through. The P event is getting heads. The number of P events that we're interested in is 4, 5, 6, or 7. And the probability of 4 or more is going to be the same as 1 minus the probability of 3 or less. Because we can calculate 3 or less, we can calculate these cumulative scores. So we're going to, the total area under the curve is 1. So since 4 or more is the opposite of 3 or less, we're going to do 1 minus the probability of 3 or less. And so we can type in our command equals 1 minus binom.dist. The number of P events that we're interested in is 3 or less. So we'll do 3. N is 7 flips. P is 0.5. And the cumulative is yes, because we're calculating 1 minus the probability of 3 or less. So we'll have true, and we'll type enter. And once again, we got 0.50, which makes sense because this probability of 3 or less was 50%. So 1 minus 50% should be 50%. Now, I want to show you an alternative way of doing this one. Here we had to do 1 minus, so you had to think about, left side, right side. Another way that we could have done this, what's the probability of getting more than 3 heads? The number of P events that we're interested in is 4, 5, 6, or 7. So the probability of getting 4 or more heads would be the probability of 4 plus the probability of 5 plus the probability of 6 plus the probability of 7, and just add those 4 possibilities up. We can do that with binomial distributions. Add the probabilities up because they're mutually exclusive. They don't interfere with each other. And so we could calculate a binomial distribution for 4 out of 7 with probability 0.5, non-cumulative, plus binomial distribution with 5 out of 7 with probability of 0.5, and so on for all 4. And actually, I'm going to copy this equation and enter it in here. I'm not going to have the apostrophe that made it a text, and it calculates it, adds up those 4 numbers, and says, look at that, it's 0.5, just like we calculated here. It's a 50% chance that we would get more than 3 heads with 7 coin flips. Okay, let's look at another one. What's the probability of getting 6 or more heads with 7 coin flips? Now so this is looking at the bell curve, just at the far right tail, the 6 and 7s. And we can do this with the number of P events that we're interested in are 6 or 7. The probability of getting 4 or more would be 1 minus the probability of 5 or less, because that gives us, in terms of area to the left, the cumulative total. So the revised number of P events that we're interested in would be 5, 4, 3, 2, 1, or 0. Number of trials is 7. The probability of a P event is still 0.5. And we want the cumulative to be true because we want to get the probability of getting, oh, look at that. That's a mistake, of getting 5 or fewer heads. Let me fix that. And so we can type this, we can type into our equation equals 1 minus, so this is so that we get the area to the right of our point, by nom.dist. Number of P events is 5, N is 7, P is 0.5, and cumulative is true, close parentheses, and that gives us a 6.25% chance of getting 6 or 7 heads. All right, let's look at the one last one, and it's what's the probability of getting an outcome that is as extreme or more extreme than 6 heads with 7 coin flips. So the emphasis here is on extreme. And when we've got a bell curve, we've got 2 tails, and things that are in those 2 tails are what are extreme. So we need to remember that getting 6 tails is just as extreme as getting 6 heads. That makes sense, doesn't it? Yeah, 6 heads, 6 tails, just as extreme. And saying if we've got 7 coin flips, 6 tails is the same thing as we're getting 1 head. And that's what our P events are. We're framing everything in P events. So the number of P events that we want to know the probability of would be the probability of getting a 0 or 1. Those are the extremes at one end. And getting a 6 or a 7, which are the extremes on the other end. So we could say that the probability of getting something just as extreme or more extreme than 6 heads would be the probability of getting a 0 or 1 plus the probability of getting a 6 or a 7. So adding those 2 tails together. So let's calculate getting the probability of 0 or 1 first. So the number of P events that we're interested in is 1 or 0. Number of trials is 7. Probability of P events 0.5. Cumulative is true. We want to calculate the probability of getting 1 or fewer heads. So we type in our binomial distribution formula, binom.dist. Number of P events is 1, N is 7, P is 0.5, cumulative is true, close parentheses, and we get 0.0625, which is interesting, because that's the same thing that we got previously, which is what we're looking for now, the probability of getting a 6 or 7. So we can, the 2 tails have the exact same area because the curve is symmetric. So we can type in 0.0625. So I do apostrophe equals 0.0625. And the probability of getting 0, 1, 6, or 7 is going to be the probability of getting a 0, 1 plus the probability of getting 6 or 7. So that equals 0.0625. Actually, let's put an equal sign in front of that. to make sure that we know it's an equation, that Excel knows its equation, plus 0.0625, which is the probability of getting a 6 or a 7, equals, and we get 12.5. So that's a 12.5% chance of getting some outcome that's as extreme or more extreme than getting 6 heads. So this covers a number of different ways of calculating probabilities with binomial distributions.